Hello everyone, in this video I'm going to walk you through question QA and it is part 4 of our ROF homework. Now you are given a dielectric waveguide. It is an asymmetric snap waveguide. The thickness of the core is 1 micron and the substrate supporting the core is a silicate substrate with refractive index 1.45. The polymer layer has a refractive index 1.77. The wavelength is 1 micron. So you are going to work out the V number, the asymmetry factor for TE mode and TM mode, and verify that there are exactly two guided TE modes and TM modes. And we are going to find the propagation constant for all the guided TE modes and TM modes, and the thickness, if the thickness of the dielectric waveguide can be reduced without changing the index profile of the structure. The question asks which of the 4 modes will be cut off first and at what value. Okay, we are going to do it very carefully. Okay, we can start now. So I'm going to switch you back to the whiteboard, and I don't need the window. So you are now looking at my whiteboard. The question details. Now the detail of the specification of the waveguide is given here. N1 is the refractive index of the core, which is given as 1.77. N2 is N of 2 is 1.45. This is the silicate layer, and N3 is assumed to be air. So the refractive index of air is 1. The thickness of the core is 1 micron. So we need to find out the V number first. K naught E, and then the numerical aperture. And K naught is 2 pi lambda, which is 1, and D is 1 as well, and then square root of 1.7 square, 1 square. So from what I can calculate is 6.378. So part 1 is done. Part 2 of the question asks for the asymmetry factor for TE mode and TM mode. So ATE is equal to and 2. And then I'm going to 1.4 square 1. So you got 1.07. And A, so I'm going to continue. ATM is equal to N1 and then 4 times. And then this guy is calculated. So if we calculate so 10.502. Sorry, this should be A. This is part A. This is part B. And this is part C. Now part D. We need to find out the propagation constant. So we need to use the V number to determine it. And I'm going to switch you to the V number. Now you are looking at the V number, the BV curve. The vertical line represents the calculated V number. The calculated V number is 6.3. So I got 6.3 here, 6.37 here. So from what you can see here, you have only 2 moles. So part D of the question, part C of the question, we need to verify we have only 2 moles. So this is exactly. So part C from the BV curve, we have only 2 moles for TE and 2 moles for TM. Now in part D, we need to calculate the propagation constant. So my suggestion here is we use the asymmetry factor to locate the exact value of P. For example, for the TE mode, you can see the coordinate here. The coordinate of my cursor can be found in here. So if I locate the so this is TE0 mode. This is mode 0. This is mode 1. The waveguide can only support mode 0 and mode 1. And if you look at here, the V number is, as you can see here, is 6.37, and the corresponding V number here is 0.0. So TE 0. Yes. P equals to 0.85. For TMO, the asymmetry factor is 10.5. So you can see from here the p value, the value of p is 0.82. So TM0 has p equals to 827. Now we look at mole 1. As you can see here, the p value is 0.42. So TE1 has a p value of 0.42. I will write it down. And TM1 has a p value is about 0.348. Okay, so we are going to use the p value to work backward to find out the propagation constant. So I'm going to switch you back to the whiteboard. So now you are looking at the whiteboard, and I have already dropped down the detail of the moles, the p value. So what you can do here is you use the formula. Say in this case for TE0, P is equals to 0.5. So we use this formula Kz over K dot minus N2. So we use this formula, and we just plug in Kz, and K naught is 2 pi over lambda is 1. So we just put 2 pi here. And N2 is 1.45, 1.77, 1.45. So by calculation, let me check the calculation. I can use MATLAB to do it. Equation and then minus 1.45 square, and then divided by 1.77 square minus 1.45 square. So I got 10.8. 10.8 for TM0. The p-value according to my calculation is 0.827. And we are going to use the same formula, but the value of p is different. And then kz2 pi so let me check the calculation. 8.27 0.827. I got also 10.8. So we can continue. I'm going to free up this space. So this is part D of the question. Continue from here. So we calculate for TE1, P is equal to 0.42 and we have 0.42 equals to kz over 2 pi square minus 1.44 square and then 1.7 square minus 4y square. And if you do it carefully, for 2. So we got 10. So kz is equal to this one. Now I'm going to raise the answer for part C and we'll continue for TM1. The p-value according to what I got here is 0.348 and we substitute 0.348 as p as the value of p. Then we use this 4 pi. So if you do a calculation, let me check. P4A. I got 9.857. 9.857. So these are the values that we need. So part D is done. Now part E. So which one is going to reduce first? We need to look at the B number. Normally it should be we have 4 moles and Okay, normally is TM mode, TM1 mode that get the cutoff first. So we need to find out the condition where the cutoff occur. Okay, now I'm going to go back to the whiteboard and I'm going to get you back to the figure. So you are now going back to the figure. Now, let me explain to you. You can see here, TE1 has the lowest value of B. So if you scan this vertical line towards the left, the first one that you have the condition of single mode operation is the one with the lowest value of B. So you can see here, if you scan it down here, you can get it here. Yeah. The other still have some value. So the one with lowest B number is the one. So what I can suggest here is we use this condition TM1 to calculate the value of D. So at TE1 we have the value of KZ equals to 9.85. And we can work out the V number based on the information. So here is my suggestion. You got the B number for this part. So the B number that you get is here. Is this one here. We need to find out the value of B corresponding to this B number. So there are many ways you can do. My suggestion is to use the graph. So let's take a look in the graph here. So if you move the vertical line and this paint-proof curve represents this T E, this one, the dark red one represents TMO. So if we scan this line, so I can see that the V number here is 4.43. Can you see the number here? 4.43. So the V number should be 4.43. So from the graph, I am going to switch you back to the Rayburn mode. So remember, you look for the mode for TM1. TM1 is this dark red one. And from what I can get is 4.43. So let's check the value. So part E from the BV curve, the value of B minimum for supporting single mode is 4.43. So 4.36. So 4.36 is the value of V. Value of V minimum, sorry. So V minimum is equal to K naught D minimum. And then the numerical aperture. So 2 pi 1, and then the value of D minimum, and then 0.436. 1.77 square minus 1.45 square. And let's check the value of D minimum. Hang on a minute, I will do it. 0.436 divided by 2 divided by pi divided by square root of 0.7 square minus 0.45 square. I got 0.68 micron. So I hope this is the expected answer. But the answer is 0.69 micron. TMO, sorry, TMO. TMO. So we need to multiply by a factor. Okay, I think I know what happened now. I got the V number wrong. Okay, this value should be 4.36. 4.36. 4.43. So let's calculate this again. Okay, so the answer is 0.48 micron. So it's consistent with the provided answer. Okay, if you have further questions about this question, please leave your comment to the comment sections. Thank you.